Good afternoon, everybody. I said I would do a lecture a day for 10 days, and so this is the lecture. I guess it'd be actually the third lecture, the second 10-minute lecture on the subject at which I am talking, and that is a geometric revolution in math. Big, scary topic. So last time we discussed the idea, and it was glossed over, and it was a little circulating, pardon the pun, but we talked about how zero comes back to approaching infinite in number theory as related to the circle, because a circle, remember, has both zero sides. You can say a circle has no sides, zero sides, then all set, and approaching infinite sides. What the heck does this mean? Why does anyone care that zero has two kinds of sides? If you're describing other properties such as area, you have one area. It's this. If you're describing radius, it's this. If you're describing diameter, it's this. If you're describing, I don't know, shading, three-dimensionality, it's this, this, this. But under that classification for side, which is the most important classification of a shape, sides, that's how we define our sides, I think. We have all of a sudden two things, zero and approaching infinite. And why are they so different? Why? Is this remarkable? I don't know. Is this circle a remarkable shape? I don't know. I think it is. It's nice. It's a nice shape. Think of the triangle, and I'm pontificating or something right now. But think of the triangle. What other list of properties would have a dual item within it in the triangle? Okay, triangle has number of sides, 3. Total area, such and such, angles, 180 or whatever, right angles, number of right angles. It's always a number. We don't have a split duality for a property in the sense of side for a circle. So I think what I'm doing now is proving that this dual property in terms of side for a shape, given the major shapes being circle, triangle, and polygon, or square, or rectangle, etc., is unique. And that is what I believe at this point. I also believe the fact that it is unique makes it significant. I also believe that because it's significant in geometry, maybe not original, and I don't know, one would have to verify this, but let's pretend it's original, okay? But being unique makes it unique, and that makes it relevant to other branches of math. And I want to tackle it. I've always want to tackle it from a number theory perspective, which is going to be hard because my knowledge on number theory is very, very limited. The best I can go about understanding number theory is understanding it through how we look at, interpret, and define numbers. And, I will need some help in this area if I'm going to develop it further. But I'll just talk a little bit about why I think this train of thought is significant. If I haven't already beaten it to death. What I always do is I go back to music, and I think that 4 is an important number in music. You have the 4, 0, 1, 2, 3, 1, 2, 3, 4. And for me, music has always been very number theory-esque. What is number theory? I'll give a child's lay definition of number theory. Number theory is the study of numbers, properties of numbers. What are numbers? What makes them numbers? Why are they numbers? What is a number? If you have, and I could be getting this completely wrong, but is 100 just as much of a number as 4? I mean, 25 goes into 104 times. So we have factors within numbers. Is pi a number? It's an irrational number, but still a number. But is it a different type of number? Sure. Is pi related to the circle? Well, of course it is. So maybe that is our first clue in unraveling this mystery of the duality of number of sides being greater than 1 and under 3, 2. So already we have a gray area, right? For the number of sides of a circle. So is it pi related? Perhaps, but so these are the questions that I'm asking, and these are the questions that I intend to utilize if I am going to provide an adequate. Well, we don't really even have a theorem yet, do we? It's more of an observation, but it's an observation that could lead to a scientific process that would develop a theory, and as a result, a proof, and as a result, a change in application / and or technology. But the purpose of this lecture isn't so much to nail down a theory right off the bat or to develop its proof, but to just think a little bit about how one could go about understanding these thoughts that I have inside of my mind and in my brain. So we've talked a little bit about number theory relating back to the dual-sided nature of the circle. We've talked a little bit about other ways of thinking about zero and approaching infinite. Last lecture, I mentioned calculus. It's quite obvious that if we have approaching infinite as a value above 0, the result is what? Undefined. The inverse is 0. So, leads me to think. Let's backtrack because I'm interested in it. At first, I thought a circle had one side because you would take a point at the top of a circle and trace it around and come back up to the top. And that to me seemed like a side, like a one side. But I think by definition, a side should be a straight line in I guess Euclidean or two-dimensional geometry. So that's why I say a circle has 0 sides. And, I do stand by that. But if you're drawing a circle, you always start at a point and bring it around to another point. Or so it may have 2 sides, it might have 1 side. But if this were a class, I would ask for comments on that idea. But okay, this lecture is a bit more lighthearted than the previous, which is fine. Anyway, revamping geometry would for me would start with this idea. I'm thinking about the knowledge of math that I do have, the knowledge of proving it, which would involve calculus, and the daunting task of doing such through calculus. So what I'm going to have to do as next steps is to go back to the drawing board and scribble out some more ideas regarding this idea. So I must first of all get to the root of the fact that a circle has 0 sides. I want the best practices regarding the ideas of how many sides the circle has. If somebody could confirm that it's 0 and not 1, that would put my mind at ease. Number theory, we have different ratios and ways of explaining properties of a circle beyond this area and circumference, sectional diagrams, sections, planar abstractions, the cylinder, etc. The circle, unique thing. And we have 1 minute left, and this has been a rambling lecture, but I knew it would be a rambling lecture, but I wanted to stick to that one-a-day principle. We have our initial thought. We've established that we don't have a theory. We have a thought, the dual nature of the sides of a circle. We have a plan or a mission statement that we need to develop and come up with a theorem that will utilize our observation or thought. And then eventually, and this will be the hardest part, I believe, we need to find proof of this theorem. The theorem that will result, I believe, is going to be a good theorem, maybe a significant theorem. And that is why I had this initial observation. I mean, we think of a scientist like Newton observing an apple falling onto his head. I think that was Newton. But, we maybe it wasn't. But an observation is a great place to start if you have these big aspirations, these big dreams, and if you're interested in science and math and the world. So thanks for tuning in for this would be lecture number 3, the second 10-minute lecture in our series. Okay, so I'm William, and we're gonna come back to this tomorrow. So have a great night, and thank you for watching. Bye.